This is a second video for section Vrap F. In this video we're continuing to look at inverse variation, but we're going to look at the graphs of y against x. Now when we are looking at inverse variation you'll end up with a hyperbola. Only the positive, we're only going to look at it in the first quadrant, so that positive side of the graph, and you can see what I mean by that shape. And hopefully you remembered that from functions. Okay, furthermore, the graph of y against 1 over x, which you see in this graph, will produce a straight line through the origin with the gradient of the line equal to the constant of proportionality k. Now don't get too caught up in the graphs again, they are only to expose you to them for future reference if you go into certain courses of undergraduate. Now an inverse variation relationship can be verified using values from the graph by checking that the product of each of the coordinates is a constant. Okay, and that's because you know that for inverse y is proportional to 1 over x, y equals k over x, or xy equals k. You can see that there. So to summarize, if one variable increases then the other variable increases, it's direct variation. And you can see that in this box. If as one variable increases the other variable decreases, then we're looking at inverse variation. So here I've got use graphs to determine which of the following have inverse variation relationships, and for those variables determine that relationship. So let's look at the first example. And I have s and d, remembering this is my dependent variable and this is my independent variable. So that means my dependent variable goes on my y-axis, my independent variable goes on my x-axis. So if I graph it directly, and I'll just pause, do that and come back to it so you don't have to wait and see me do it. Okay, it doesn't look great, but you can see what I'm getting at. So when d was 15, which is here, I have s is around 640, when d is 20, 480, etc. And you can see that I'm getting that curved graph. Okay, and that keeps going. So it's indicating inverse relationship. If I come back to sketch 1 over d, so now I'm doing 1 divided by 15, I get 0.06, 1 divided by 20, 0.05, 1 divided by 53.3, I get 0.01875, 1 divided by 60, I get 0.016 recurring. Okay, so now if I wanted to check, I can work out k is going to be s times d. So I've got 640 times 0.06. Now you've approximated, so you might not end up with exact answers, but if you multiply the s values with the d values, you should get 9,600 all the way along. Sorry, so 640 times 15. I think I might have said that the wrong way around. Sorry about that for any confusion. So 640 times 15 is 9,600. 480 times 20 gives me my 9,600. So I'm doing s times d. Now if I graph 1 over d with s, so when 0.06, and again this is going to be a bit difficult because the numbers are so small, but 0.06 and I get s as 480. Which is up here, and I'll keep going. Okay, I think it's one of those videos where I keep making mistakes. Okay, when I had 0.06, s was 640, which is approximately there. When I have 0.05, I get 480, which is approximately there. And then when I have 0.018, I get 180, which is approximately there. So you can see that it looks like a straight line, and it's starting at the origin. Okay, what we can see now is because we are getting that straight line graph, k is equal to my slope. If I use 2 points, again remember we're looking at the, and I'm going to take away that highlighting, we're looking at s versus 1 over d. So let's work out what our slope is. K is going to be equal to, again it's y2 minus y1 over x2 minus x1. So if I have 160 minus 640, so I'm looking at these two values here, all over. I'm going to keep my exact values, so 1 over 60 was this value here, minus 1 over 15 for that value there. And you should get 9,600, which you already worked out by multiplying here. Okay, so you've just proven that. So S is proportional to 1 over D, S equals K over D, S equals 9,600 over D. Again, don't get too caught up in this graphing. Next, area millimetres squared, radius metres. Again, that's my dependent variable, that's my independent variable. Go ahead and draw your graphs. So you've got 10, 314, which is about there, 15, 706, which might be about there, 20 and 1256. Again, you can see that this is a curve that can start here. Now the graph isn't a hyperbola, so it's not inverse variation. Okay, so we haven't got inverse variation. What we do seem to have is direct variation. So what we can do is work out what r squared is, which is going to be 100, 225, 400, and then we can graph that. So we've got r squared's 100 and area is 314, r squared's 225 and area is 706, about there, and then we've got r squared's 400 and 1256, which is about there. So you can see that we've got a straight line starting at 0, 0. Okay, so the graph isn't a hyperbola, so it's not inverse variation. Okay, but it is direct variation because A is proportional to r squared, so A equals k r squared. If you go ahead and find the slope, and I'll work that over here because I don't have enough room, slope would be 1256 minus 314, I'm just going to use these points, all over 400 minus 100, which would give you the 3.14. Okay, so now we come back to this formula. Area is going to be 3.14 r squared, and that's your circle. Okay, next, height and radius. You would have to start from scratch for these graphs. I'm not going to go into these details. It is all in your textbook, and I think I've done enough now for you to be able to work it out from your textbook. And that's the same with this last one. Different resistors are placed in an electrical circuit. So, and the current flowing through the circuit is measured. The following results are obtained. Look at your textbook for the graphs that verify the relationship is inverse. When you do I versus R, you get a hyperbola, or half the hyperbola. So then you do I versus 1 over R, and you get that straight line. Okay, so that's verifying with a graph that it's inverse relationship. Your other way is to work out K equals IR. So you multiply these values along, and you should get 12 every time. So that's another way of verifying it. So when I'm doing the relationship, I know that I is proportional to I is proportional to 1 over R. So I equals K over R, and I know K is 12. So I equals 12 over R. Okay, so please have a look at the textbook for that explanation. I don't want to bore you through these videos and make them longer than they need to be. So what now? Vrap F1. Don't just think that they're all graphs. The first lot are just our application problems from our previous video, so please make sure you do those questions. Again, don't get too caught up with the graphing.